All right, this is the Fraction Operations Unit Test C. We're using this version of the test as a practice test because it's very similar to what you're going to see on test day. So I'm going to go over the entire practice test step by step so you can see what you got right, what you did wrong, how to fix your mistakes. As you watch this video and go through your work, if you made a mistake and got the wrong answer, you need to copy down the correct work and the correct answer so that when you study, you have all the good answers. All right, number 1, find the length of the rectangle below. They gave us our width, we have the area. I know area equals length times width. So since they gave us the final answer and one of the dimensions, I'm going to take our final answer, 1 1/4, and divide it by our width, 5/6, to find our length, okay, to find that missing measurement. So I can't use the keep change flip right now because I need to turn this back into a improper fraction using the MAD-C method. So 4 times 1 is 4, 4 plus 1 is 5 fourths divided by 5/6. Ready for the keep change flip. Keep 5/4 multiply by 6/5. I can use the Band-Aid method and simplify before I multiply because these 5s, their common number is 5, so they're both going to turn into 1s. So now it's just, oh, and we can also use the Band-Aid method for 4 and 6. The common number is 2, so it's going to turn into a 2 and a 3. So now it's 1 times 3 equals 3, 2 times 1 equals 2, and then 3 halves simplified, turned back into a mixed number is 1 1/2. So the answer was B. Number 2, a small carton of milk holds 4 cups. A recipe for an iced coffee calls for 1 1/3 cups of milk. How many iced coffees could you make with this one carton? So I'm going to take everything we have, which is 4, and we're going to split that up by how much we need for each recipe, which is 1 1/3 cups. And now we want to know how many iced coffee drinks can we make. So I'm going to turn my 4 into 4/1, so I have a top and bottom, divided by, got to use that MAD-C method. 3 times 1 is 3, 3 plus 1 is 4, so 4/3. Now we have numerators and denominators, so ready for the keep change flip. Keep 4/1, multiply by 3/4. I can simplify. 4/4 turns into 1/1. Now multiply straight across. 3/1 equals 3 iced coffees with that 1 carton of milk. Number 3, Isabel poured 1/5 of a cup of chili powder into a spice jar, filling it 1/2 of the way. How many cups of chili powder will fill the entire spice jar? So I used my 1/5 cup of chili powder and it filled half of the spice jar. So I'm going to split it into a 1/2 section. So I want to know how many 1/5s we'll need to fill the entire spice jar. So we're going to use the keep change flip. Keep our 1/5, multiply by 2/1, and I get 2/5. We'll need 2/5 of chili powder to fill the whole spice jar. Okay, because we had 1/5 and we filled it halfway. So guess what? This other half is going to be the equal amount. And you put those two together and you get our answer, 2/5. Number 4, a recipe calls for 4 cans of cream of chicken soup. There's our 4 cans. Each can has 1 1/4 cups of soup. How many cups of soup does the recipe call for? Well, I have 1 1/4, 1 1/4, 1 1/4, 1 1/4. So we're going to do 4 times 1 1/4. I can't multiply right now because I can't multiply with a mixed number. So I'm going to use that MAD-C method. And we're going to, 4, 1's going to stay the same. 4 times 1 is 4, 4 plus 1 is 5, 5/4. Okay, we can simplify before. 4 over 4 becomes 1 over 1. 1 times 5 is 5, 1 times 1 is 1, which is just 5. If you didn't simplify before you multiplied, you would have had 20 over 4, which also simplifies to 5 as well. So 5 cups of soup, the answer is A. Number 5. Mateo is putting soil into flower pots in his garden. He has a bag with 9 3/8 quarts of soil remaining that he will use to fill 5 flower pots with the same amount of soil. How many quarts of soil will be in each flower pot? So we have 9 3/8. That's all of our soil, and we're splitting that up in between 5 flower pots. So let's see how many quarts of soil will be in each of the flower pots. So MAD-C method, 9 times 8 is 72, 72 plus 3 is 75, over 8, divided by 5 over 1. Now that we have numerators and denominators for both, I'm ready for the keep, change, flip. 75 over 8 times 1 over 5. Okay, if you multiply straight across, you're going to get 75 over 40, which equals 1 35/40. But we're still not done. That needs simplified more. I'm going to use the Band-Aid method. 5 is going to be my common number. How many 5s make a 5? 1. How many 5s make a 75? 15. So I'm going to go 15 times 1 and 8 times 1. So that's going to turn into 1 7/8. And up here, our common number would be 5 to simplify our fraction. How many 5s make a 35? 7. How many 5s make a 40? 8. Okay, so in each of the flower pots, there will be 1 7/8 quarts. Number 6. Sage is making hair bows out of ribbon for her cheerleading team. She has 8 3/4 feet of material and needs 1 1/5 foot of material for each bow. How many complete bows can she make with the existing material? Make sure you pay attention. It says how many complete bows. So we have 8 3/4, and we're splitting it up into how much we need for each bow, which is 1 1/5. So we have to do the MAD-C method for both numbers. 4 times 8 is 32, 32 plus 3 is 35, 35 over 4, divided by 5 times 1 is 5, 5 plus 1 is 6. Now we're ready to use the keep, change, flip. So keep 35 over 4 and multiply by 5 over 6. This one you cannot use the Band-Aid method for. There is nothing that can be simplified prior to multiplying straight across. When you do multiply 35 times 5, you're going to get 175. And 6 times 4 is 24. But we can't leave our answer like that. That's an improper fraction. It's a no. So if I figure out guessing and checking how many 24s fit into 175, I end up getting 7 of them. And 24 times 7 is 168. So if I take 168 pieces off the top, that means we have 7 left out of the 24. Now the final question, or final answer, you have to reread that question. How many complete bows can we make? Well, we can make 7 of them, and then we can start the 8th bow but we can't finish it. We don't have enough material. So the answer to this question is just the number 7. You have to be careful with that one. All right. Multiplication. So, can I simplify beforehand? Yes. This one, the 5s and 10s. 5 is my common number. How many 5s make a 5? 1. How many 5s make a 10? 2. So, multiply your tops. 1 times 3 equals 3. 11 times 2 equals 22. All right. Number 8, dividing. So, keep, change, flip. Remember, if you have a whole number, always put a 1 underneath it. I like to do the keep, change, flip after I have tops and bottoms for both fractions. So, keep our 3/8, change division to multiplication, and flip so it's 1/4. Multiply straight across, and you're going to get 3/32. All right, number 9, we're going to skip. Skip number 9. Number 10, Kennedy pays her car insurance bill every 4 months, while she pays her home insurance bill every 6 months. After how many months will she pay both her car and home insurance bills in the same month? So we have to find the least common multiple between our 4s and 6s. We want to know when is the first time that those bills are going to match up on the months. So if you're using your multiplication chart, you need to look at your 4s row and your 6s row and decide what's the first number that matches in both rows. Okay? If you're going to write out your multiples, 4, 8, 12, 16, 20, 6, 12, 18, 24. They both have a 12. So it'll take 12 months, which is letter C, for her car and home insurance bills to be in the same month. Number 11, a piece of copper wire measures 9 feet. Graham would like to cut it into equal portions, each measuring 4/5 of a foot long. How many pieces will Graham be able to cut from the copper wire? So I have 9 feet of wire, and I want to split it into 4/5 size sections, and I want to know how many pieces I'll get. So anytime you have a whole number, make sure you put it over 1, 9/1, okay? Now we're dividing, so we're going to keep, change, flip. Keep 9/1, change division multiplication, and flip, so it's 5/4. 9 times 5 is 45. 1 times 4 is 4. How many 4s can we fit into 45 without going over? 11 of them. 11 times 4 is 44, which means we just took 44 pieces off the top, which means we'll have 1 left, and keep your denominator. So I'll have 11 and 1/4 pieces. All right, number 12. Kendall is making sushi rolls for a dinner party. She has 4 1/5 cups of rice. If each sushi roll requires 2/3 cups of rice, how many sushi rolls can she make? So we have 4 1/5, and we need to split it up into 2/3 sized sections to figure out how many rolls we can make. So we're going to divide since we're splitting that rice up. I can use the keep, change, flip, but I can't yet because of that mixed number. So Mad C method, 4 times 5 is 20, 20 plus 1 is 21, so we have 21/5 divided by 2/3. So ready to use the keep, change, flip. 21/5 we're going to keep, change to multiplication, and flip so it's 3/2. 21 times 3 is 63. 5 times 2 is 10. Improper fraction, do not keep that. How many 10s can we fit into 63? 6 of them. 10 times 6 is 60, so we will have 3 pieces left up top, and keep your denominator. So she can make 6 and 3/10 sushi rolls. She can make 6 full sushi rolls. All right. Number 13. Alex filled a watering can with 4 quarts of water. He used 1 1/4 quarts of water for the plants in his house and 1 5/8 quarts of water for the plants on the balcony. How much water is left in the watering can? All right. So we're starting with 4/1. And we need to get rid of the amounts of water he's already used to see how much water we have left. So minus 1 1/4. I can't do this right now for 2 different reasons. One, I need to turn this into an improper fraction. And 2, we have to have common denominators. So this is going to be 4/1 minus 5/4. Well, I'm going to turn this first fraction into, or multiply by 4 so that our common denominator is 4. So rewriting that, 4 times 4 is 16, 1 times 4 is 4. So 4 is the same thing as 16/4, minus our 5/4. Okay, 16 minus 5 is 11. Keep your denominator 4. Now we need to subtract our final part, which is, I'm going to turn this into MADC method improper fraction. 8 times 1 is 8. 8 plus 5 is 13. So minus 13/8. And you're like, I can't do 11 minus 13. True. However, we don't have common denominators right now. So I'm looking at my 4s and my 8s, and the first number that matches, my least common multiple, is 8. So I'm going to multiply this first fraction by 2. And I got 22/8 minus 13/8. Okay, so then when you when you subtract these, I get 22 minus 13 is 9, common denominator 8. So 9/8, improper fraction, turns into 1 1/8. He will have 1 1/8 quarts of water left in the watering can. All right, so number 14, the perimeter of a triangle below is 10 centimeters. Perimeter, remember, means we added all the sides up. Okay, adding all the sides up. That's a plus sign. What is the missing side length? X. Okay, there's our missing number. So we're starting with 10, and we need to get rid of that amount and that amount to figure out what we have left. So I'm going to do 10/1 minus 3 1/6. However, I'm going to use that MADC method. No, I'm not. I lied. Minus 3 1/6. Okay, we're going to start with that. Now, I'm going to turn 10/1 into, it's a 9, and 6/6. I know I want my common denominator to be 6. And I know if I take one whole piece out, then I have 6/6 for my 10th piece. I'm doing this because I can't do 10 0/6 minus 3 1/6. Okay, you can't do 0 minus 1. So we needed to regroup, cross off your 10, make it a 9. Now you have all these 6 little pieces just floating around looking for a home. They're going to find their home up top. So 9 and 6, 6 minus 3 1/6. All right, subtract your fractions. 6 minus 1 is 5/6. And 9 minus 3 is 6. Now we have to subtract 6 and 5/6 minus the other side. But I need to have common denominators, so I'm going to multiply this fraction by 2. So 4 2/3 actually becomes 4 4/6. Subtract your fractions. 5 minus 4 is 1. Keep your denominator. 6 minus 4 is 2. So our missing side is 2 1/6 centimeters. All right, 2 more. Number 15, we're going to use the keep, change, flip. Make sure your whole number has a 1 on the bottom. Now you're ready to use it. Keep 7/8. Change, division, multiplication, and flip so it's 1/2. Multiply straight across. I get 7/16. All right, last one. Which of the following is the greatest common factor of 48 and 96? Okay, this one, bear with me. Okay, I'm going to use the ladder method, okay? Ladder method for GCF. So I've got 48 and 96. So I'm like, what smaller number can I use to multiply to get 48 or 96? It has to work for both. And the first thing that comes to my mind is 12s. So I'm going to put 12 on the outside. I'm like, how many 12s make a 48? The answer is 4. How many 12s make a 96? The answer is 8. I draw my next ladder step. And I'm like, what goes into 4s and 8s? Well, the biggest thing I can think of is a 4. So I'm like, all right, how many 4s make a 4? 1. How many 4s make an 8? 2. And I look at my next step and I'm like, I can't break those up anymore. So to find the greatest common factor, circle your outside and multiply. I get my greatest common factor equals 48. However, that's not one of the options, is it? No. So we found the greatest common factor. However, the question was, which of the following of these choices is the greatest common factor? So the biggest number that works for both is not 8, is not 12, is not 16, it is 24. Okay, it's actually our greatest common number cut in half. Okay, 24 times 2 is 48, and 24 times 4 is 96. So that is the biggest number that will work for both. But the actual greatest common factor is 48.